So welcome all. This is the EuCAPT profile series, which consists of interviews with key members of the community active in theoretical astroparticle physics and cosmology. So in these interviews, we discuss what's exciting in research, life in academia, and developments in the research community. So my name is David Marsh. I'm an assistant professor at Stockholm University. And today I'm excited to be joined by Foteini Oikonomou, who's an associate professor at the Norwegian University of Science and Technology in Trondheim, and is an expert in high-energy astroparticle physics. So welcome, Foteini.
Hi, David. Thank you very much for the opportunity.
So let's start by getting to know you a little bit. So first up, so where are you from, and how did you become interested in science?
Yeah, okay. So I come from Greece. I grew up, I was born and grew up in Athens, Greece. And the one thing that I can remember that sparked my interest in astronomy really was the first visit I had to the observatory of Penteli, which is not far from my parents' home. And at the time, the airport was not there, so you could see really nice skies. And so, it was the first time that we looked at some star clusters, and I became aware that the light had taken such a long time to reach us. So that sparked an interest, which then these were days without internet. So I followed up by going to open evenings and reading popular science books. And then, when time came to study something at university, I wasn't really ready to choose a career. But then I thought, well, that's something, that's fun and I want to study. So that's my story.
Yeah. So curiosity driven from the start.
Yeah, and also a random walk in a way, because I
Yeah.
didn't know at that time that would develop into a career. It was
Right.
just,
Right.
yeah.
Okay, so speaking of career, what has it looked like for you? What's your career trajectory? What positions have you held, and where and when?
So I moved to the UK for my undergraduate degree. At the time, there were no fees, so that was a possibility. I was one of the lucky last years, and because they had a big tradition in astronomy and astrophysics, and at the time I thought I really want to study astronomy. I don't want to bother with all the other physics. So I moved there, and then I did my PhD at University College London in the astrophysics group. At the time, there was an umbrella collaboration with the particle physics group called the Origins program. So that was my first stop, and then I went to the Pennsylvania State University for a position at the Pierre Auger Observatory. During that time, I held a fellowship of the Institute of Gravitation and the Cosmos, and worked also on phenomenology. So I transitioned more towards phenomenology in that position. From there, I went to Munich, and in Munich, I was at the European Southern Observatory, and there was a group of people very interested in active galaxies as sources of neutrinos, and there was a strong collaboration with the NICE-CUBE group at the Technical University of Munich. So that was my how my time there was spent between these two groups. And that was for about 2 years until I got offered the position that I have currently, which, so in the Norwegian system, we go directly to an associate professorship. And I've been here now for the last 3.5 years.
Good. Yeah. So thematically, in terms of the research, you've already mentioned how you transitioned a little bit between different topics. Can you tell us more about that? How has the research focus of yours changed with time?
So in terms of the topics, I started from ultra high energy cosmic rays, and they're really, I'm trying to figure out what are the sources of these extreme particles. And after I started my PhD, and that's an interest that I haven't lost, so I'm still very much working on that, but only after I started my PhD, astrophysical neutrinos were discovered. And so during the time at Penn State, I started working also on high energy neutrinos. And by now, I would say, you know, I'm equally interested in both, and also on something which I think is going to become more and more topical, but it really started at Penn State, at least for me, and that was looking for multi-messenger transient alerts, and you know, then assessing whether an association is physical or not. So we had the Astrophysical Multi-Messenger Observatory Network there. So those, and then those are the topics. And I'd say in terms of just what I do on a day-to-day basis, I moved more from like an analysis profile. So I was doing high-level data, of course, by analyzing and doing statistical analyses. And now I'm moved more to the actual source physics and trying to understand what might be the physical conditions in a particular source. Can it accelerate particles? You know, what is the magnetic field? Things like that.
And do you do modeling in that aspect too?
So I've moved more to the modeling. Yeah.
Cool. And at the moment, so what question is it that you're most excited about in your research area?
So it's a difficult question, but I mean, you know, I think I have to go with cliche, and it's an age-old problem, but I'm very excited to figure out the sources of the highest energy particles. And so in terms of cosmic rays, the highest energy cosmic rays, what's really exciting is that with more data, we're being met with a kind of like a mystery where the plot thickens, because what we're observing is not what we expected exactly, even though we had very well motivated theories, which make perfect sense to me. The data that we're now measuring are just not doing what we expected. So it's a kind of real puzzle. And then also in terms of looking for the sources of high energy neutrinos, that's another very exciting thing, in the sense that, you know, it's only been 10 years that we have any neutrinos to work with at high energies. And already we've been able to rule out the most obvious suspect sources, like gamma ray bursts, jetted active galaxies, as the main sources of these neutrinos. And again, I'm very excited about this question, not least because now we understand that, you know, the sources are relatively numerous and relatively ordinary, and so it's going to be difficult to find them.
It's going to be difficult to find them, do you say?
Yes, in the sense that, you know, the rarest ones are the ones that we can most easily test, and we've ruled them out already in a decade. So the challenge is not the easiest one that nature could possibly have thrown at us. So it will require more, you know, smart analyses, new models. That's what I meant when I said difficult.
I see. Okay, so moving more into sort of life as a scientist. What do you like about being a scientist, and what do you dislike?
So, well, first of all, I really like being a scientist, and I think for the most part also my colleagues, you know, it's a bit like being a musician. Nobody chooses a career in science to pay the bills. People do it because it's a passion, and many people describe, and myself included, describe it as their hobby. So I think it's just a privilege to have a job where you get paid to do something that you're just very interested in. So that's what I really like.
And any dislikes?
Yes, also. Well, I can speak about my current position now as a faculty member, and you know, I without disliking any particular role, like I have to write grant applications, I have to evaluate grant applications, I have to teach, I have to evaluate the teaching of colleagues and so on. I dislike having to do everything at once because I feel that, you know, I'm just not very good at doing many things at once. So I dislike this kind of fractured attention that we're required to have.
Yeah, yeah. I feel that's very common. It's precisely a point raised by several other people that we've interviewed in this series. All right. So are there any advances or new results that you're excited about and looking forward to in the near future?
So first of all, I mentioned cosmic rays and ultra high energy cosmic rays, and there is currently an excess of events in the direction of the nearest radio galaxy, Centaurus A, which is at the level of 4 point something sigma post-trial, I forgot exactly, and it's been growing for a long time. So, you know, I'm excited to see whether in the next 5 to 10 years this will cross the 5 sigma or disappear, but to me that's going to be a momentous result if it grows. Then I think just in terms of, because there are new neutrino experiments coming online like KM3net, and also IceCube is going to be upgraded and will have eventually better models which will help have better angular resolution. So that's something I'm personally, you know, very excited to see the new data and work on them. And then something which is not exactly, you know, in my immediate field is this recent hint of gravitational waves from supermassive black holes from pulsar timing arrays. So I'm really excited to see whether that grows. And also, you know, there is a possibility that within a decade, these pulsar timing arrays will be able to localize a single system of merging supermassive black holes if what they now see is a real signal. So I'm really excited about that.
Right, right. So in terms of the Taurus A cosmic ray excess that you mentioned, do you have any favorite sort of potential explanations of what could cause this?
So this is a source that just because of its proximity, more or less, I mean, I don't even know how many hundreds of papers are there as to that this would be the first source to be discovered. So just by reaching the 5 sigma threshold, I think, having seen the 4 sigma data, I don't think we'll be able to distinguish between models. But I do think we'll be able to, you know, confidently, well, I don't want to say super confidently, but somewhat confidently say that what people thought for a long time, that active galaxies with large jets can accelerate the highest energy particles, will become, you know, something to really take seriously as a possibility. So that would be the big breakthrough there.
Right, right. So what do you regard as the biggest obstacle to progress in astroparticle physics at the moment?
So I suppose, first of all, I consider it a really data-driven field, even though I'm more on the theory side of things. On the one hand. On the other hand, the data sets we're working with are just tiny. So we have now 100 cosmic rays, somewhere close to, in energy, somewhere close to 10 to the 20 electron volt collected over 15 years. So compared to an astronomy experiment, this is just ridiculously low.
Yeah.
And, you know, the low statistics are the ultimate challenge of the field. Now, of course, behind this is either we need more, either we need bigger experiments, that means more funds, or we need to come up with better technologies where we can more cheaply build larger detectors. So somehow I think it's a joint challenge of funding, but also developing new and cheaper technologies, because in the end we'll have to instrument a large fraction of the Earth's surface, and we cannot possibly just go with our current designs in a way.
Right. So perhaps related to that, so what do you hope to see accomplished scientifically in the next 50 years?
Well, so of course I hope that some of these, so there are a lot of, I'll just talk about my field, and there are a lot of experiments proposed, and I think they're all excellent ideas, some with overlap, both on the neutrino side and on the cosmic ray side. And I think it has been demonstrated by the current generation of instruments that we're in a position within the next 50 years to solve both the mystery of the origin of the cosmic rays and of the neutrinos. Also, I think we can discover ultra high energy neutrinos. That's what we call cosmogenic neutrinos from the interactions of the cosmic rays. And it's not trivial to say that, because the cosmic ray problem is more than 50 years old. So, but I think we now know enough that we can be confident that the next generation of experiments could make important discoveries.
Okay. So switching topic a little bit to EuCAPT, actually. So EuCAPT is formed to seek to stimulate astroparticle theory in Europe. What do you think EuCAPT can do in this respect? What do you think the role of EuCAPT is?
Okay, so also I think for me, my involvement with EuCAPT really started properly during the pandemic, and in that time it played a major role in bringing us together. At a time where there were not many conferences, certainly not physical ones, and it really, I feel like it really did bring us together. I've been to some EuCAPT meetings, and I think it's wonderful to get to know people working on similar topics and learn from each other. But also just being stronger together and being able to, we're an interest group. We can advocate for the interests of the group better together. And there are these several initiatives. We talked just before starting the recording about, the having the certain web events. I'm involved in the efforts to look at possibilities to attract funding together. In another EuCAPT committee, there are the colloquia, which I really enjoy. And I think all of those are really nice things in getting us to know each other, to form a network, to reach out to each other, and yeah, all of those things.
Okay, cool. Okay, so trying to get to know you as a person a little bit more. So what do you do when you're off work? What do you do for fun? Do you have any interests that you like to sort of share with everyone?
Yeah, I guess the main one that I've had throughout my life, because I'm an only child. I just like reading. So I mean, when my friends went on playing after our play dates with their siblings, I went home and there was no internet. So I like to read fiction. I like to read popular science and history. That's my one hobby that has withstood time. And then the other things somehow change depending on where I am in the world. So for example, here in Trondheim, there are endless opportunities for hiking, so I really try to make the most of that, and everybody that visits me also. So yeah, that's a kind of a hobby,
Right.
a local one. And I'm trying to learn to cross-country ski, but I wouldn't mention that as one of my hobbies yet because I'm a beginner.
Right. Yeah. I think it's just a condition for living in Norway is that you learn cross-country skiing.
Exactly. I'm more or less contractually obliged
Yeah, right.
to learn. Yeah.
Yeah. So on the topic of novels or popular science, do you have any suggestions, anything good that you've read over the past few years that you'd like to share? Sorry
Oh,
for putting you on the spot.
that's oh no, I love this question. So right now I'm reading this book called An Immense World by Ed Wong, and it's about all the different things that that scientists have learned recently about how animals see and how animals hear, and there's even a more speculative chapter that I haven't gotten to yet about how whales, do their migration.
Mm,
And so I've already recommended this and bought this for members of family for Christmas because I really enjoyed it. So that's the first one that came to mind.
great, great. Yeah, I'll definitely check that one out. Okay, so final question from me is, so what advice would you give your younger self or a younger colleague who are just sort of starting out in astroparticle physics at the moment?
Mhm. I think one thing that I wish I had done more of is reach out for help or reach out for feedback, reach out for advice, reach out for just ask. So I think my feeling was always that busy people don't have time, and I better try and figure it out on my own.
Right.
But in the times when I've broken this rule in my mind, I've been really always positively surprised by the wisdom that people have and the generosity they have in share. Busy people make time when something matters to them, and usually and I think it can be invaluable to have a more senior person's perspective on how to navigate difficulties or just to have more feedback. So yeah, I hope this is valuable to other people as well. So just asking
Right.
for
So
feedback
make
or help.
use of potential mentors.
Exactly.
You
Looking
surround
for
them.
mentors. Exactly. Yeah.
Yeah, that's good advice.
Mm.
Okay, so thank you. So that's all for this interview. Thank you very much, Foteini, for sharing with us your perspective and your research topics and your hobbies.
Thank you very much.
So more EuCAPT profiles will appear on the website and on the YouTube channel named EuCAPT in the future. So please keep that in mind and check it out. Thank you very much for joining us, and thank you again, Foteini.
Thank you.